Okay, here are the solutions to review quiz 3.1. For question 1, we need the product rule. So here, dy dx, we're going to have the first times the derivative of the second plus the second times the derivative of the first. And so that looks like that's going to give us answer choice B. Now moving on to number 2, this looks like you might have to do a u substitution, but it's really just a derivative value here. You're asked here, what is that the derivative of? And that is the derivative of secant x. So our answer should be A. Okay, for number 3, we want to know where, on what intervals is the function f increasing. And we know when f is increasing, then f prime of x is greater than 0. So it would be great if we had a graph, but we don't. But I bet we could come up with something. So let's look at f prime of x. That's going to be 300 minus 3x squared. And if I set this equal to 0 to find those critical points, notice that 3 is a common factor. So I'm going to factor out 3, and I have 100 minus x squared. And then if I factor that, I have 10 minus x times 10 plus x. So notice that all of this tells me things about f prime. F prime, if you'll notice, is a parabola, negative coefficient, so it's upside down. And notice where we're crossing the x-axis at 10 and negative 10. So really, if we wanted a quick sketch of the second derivative, here is, or the first derivative, here's f prime of x. And so now we just need to know, well, where is f prime of x positive? And it's positive from negative 10 to positive 10. So our answer is B. Okay, the next problem here, we've got to evaluate the value of f prime at 1. So first let's find f prime at x, and that's going to be 7 plus 1 over x. Derivative of natural log of x is 1 over x. And then f prime at 1 is going to be 7 plus 1 over 1, which is 8. For this problem, we need to see over which of the following statements would be false. So let's start with A. We have the limit as x approaches 2 exists. So remember our limit, since this is not one-sided, you do need to trace in from the left and from the right. And notice we are approaching a specific value. Now we're not equal to, that just means we're not continuous there. But we are approaching 2, so that one does work. So for our next one, the limit as x approaches 3 of f of x exists. So by the same idea, are we approaching as we get closer and closer to 3 from the left and the right? We are approaching a specific value, so that one is true. What about the limit as x approaches 4? So here from the left, that's not approaching the same value from the right. So this one, answer choice C, is the one that is false. Okay, for our next problem, we have a particle is moving along the x-axis, and the velocity is given by this function here. So I know v at t is 6t minus t squared. What is the total distance traveled? So let's keep in mind this is PVA, position, velocity, acceleration. We are at velocity, but we need total distance, or a position that the function has traveled. So we're really looking at moving up this chain of events, and that is going to be area. And we said that was your antiderivative. We're undoing. And so we want that total distance from 0 to 3. So here, remember, this was our derivative, dy dx, or however, but the antiderivative an application of that was area, which is our integral. So really we could integrate 6t minus t squared from here 0 to 3 dt, and that would give us our position. So let's see what we're going to have. 6t squared over 2 minus t cubed over 3, and we're evaluating that from 0 to 3. I would cancel that, and so that's going to be 3 times 9 minus 27 divided by 3 minus 9. And then, of course, all of that's minus. If we plug in 0, we're still going to have 0. So we're going to have 27 minus 9. So that's going to give us an area of 18, or a position in this case. So that's answer choice D. And this next problem, we have the chain rule that we're going to have to use because we have really a function inside of this other function. And so our chain rule, first thing, and if you forget this chain rule, look at your answer choices to help you. This is really your first step of the chain rule. 5 times x cubed minus cosine x all raised to the 4th. But now you're not finished with it, but I can eliminate several answer choices. And notice what's left. And so part D here, again, it looks like you're on the right track, but you're really not because they did the derivative of the inside. So even without finishing the problem, you see the answer should be E, but I do want us to go ahead and finish the problem. Here you do address this outside function, do that chain rule first, and then it's times the derivative of the inside, so that's where our 3x squared plus sine x comes from. For our next problem, not function, my goodness, we need to see, well, where is this continuous? And we talked a lot about great, wonderful, different theories in it, but really all it comes down to is a matter of setting these two values that were given equal to each other and plugging in 2 for x. Well, we do need to simplify this side over here. So I have 2x plus 1 equals k. And now I'm going to bring in that x has to be 2. So that's going to give me 4 plus 1 has to be the value for k. So that's answer choice E. Okay, now this is using our U substitution. And notice it's asking you if we do this U substitution here, then this becomes which of the bottom. So the first thing I would look at to eliminate some answer choices would be the fact that if U is equal to the square root of x, then when U is used down here, in which it is, if we notice all of those have du, then you can't have the same endpoints. And so that's something you have to keep in mind. So let's see what the endpoints would be for U. So for that first one, it's going to be the square root of 4, which is 2. And then the bottom one is going to be the square root of 1, which is 1. So automatically, I know I have to be going from 2 to 1. So that's going to get rid of E, B, and A. So now we have 50-50 shot. And either we are going to have an extra 2 in the bottom or 2 in the top. So we do have to finish doing the U sub, but if we're pressed for time, we've got something pretty good to go off of. So now here, once we assigned U, we had to find du dx, which is going to be 1/2 x to the negative 1/2. And we always solve for dx. I would try to simplify this other side though, because we've got a lot of fractions and stuff. This is going to be 1/2x to the 1/2, and that's going to make this easier to solve because we're just going to cross multiply. And so I have 2x to the 1/2 du equals dx. And now let's go back up and do our substitution. So we have the integral of e to the u over square root of x, or x to the 1/2, and then dx is equal to 2x to the 1/2 du. And so we see our x to the 1/2 cancel. That 2 is in the top, and so that's what gets moved out. So our correct answer is C. Number 10 is just a good application of dividing up our area. Now, again, this is kind of a strange looking problem. We know f of x, that's going to be what's over here, but we have two different things going on with f of x. F of x is the value of 2 for everything that is less than 3. So notice over here, we have a less than 3 part in this, so I'm going to have to divide this up. It's like a piecewise function. So I'm going to integrate from 1 to 3 of f of x, and that's going to take care of the top part, and then plus, and then I'm going to finish the integral with 3 to 5, and that's going to be this bottom portion of f of x. And so notice we have two different parts that we're going to have to integrate here. So for the first one, we're really integrating from 1 to 3 of 2 dx plus the integral from 3 to 5 of x minus 1 dx. And so if we integrate 2, we have 2x, and that's evaluated from 1 to 3. And if we integrate x minus 1, we're going to have x squared over 2 minus x, and that's evaluated from 3 to 5. All right, so for our first portion here, we're going to have 6 minus 2, that's the first part, plus, and then plugging in over here, we're going to have 5 squared, or 25 over 2, minus 5, but then we've got to come back and plug in the bottom part, so minus 9/2 minus 3. So now we've got a lot of algebra here, or just number crunching. So we have 4 plus, I would go ahead and do these over 2. So 25 minus 9, that's going to give me 16 over 2. And then minus 5 minus a negative 3, so minus 2. So this is going to work out nice. You have 2 plus 8, so we get 10 for our answer choice. Our next problem, we're given that f of x is equal to the integral of g of x, and which of the following could be the graph of y equals g? Well, how in the world are we going to get there to the graph of g when g is defined? We're not real sure, but I do know over here to the side that f prime at x, that's equal to g at x. So if I knew what this derivative looked like, then I would know kind of a good idea of what g of x would look like. Well, I'm given f, and notice this is a linear function. It has a positive slope. And so that tells me that the derivative would be some kind of constant positive value. So my derivative really is going to be up here somewhere since it is a positive slope. So where could I find that down here in our answer choices? Well, let's see. We've got, it looks almost like either A or B, so I'm going to go ahead and cross out these. Now, the only difference in A and B here, let's look and see. Well, B, the line is down below the x-axis, and A, the line is above the x-axis. Since I have a positive slope, that means that all these values for f prime, which is g of x, have to be above the x-axis. So the correct answer is A. And finally, number 12, we are given the graph of f at x, that is the derivative of f. Which of the following statements must be true? So beyond a shadow of a doubt has to be true. So let's pick out some things we might know. Let's look at f has a relative minimum at -3. So let's pinpoint -3. So it's right there. And what things would make that true? Well, if f has a relative minimum at -3, f prime at -3 would have to be 0, and it is, so check. And then for us to have a relative minimum, f prime has to go from a negative to a positive. F prime would have to go to positive because a relative minimum, notice my slopes change from negative to positive at a relative min. And right here the slope is 0. So yeah, this one could be right. That one could be true. So I know that's going to get rid of those for sure. So unfortunately we're going to have to check 2 or 3. And so let's look. Either way we want to do this. We can either talk about a point of inflection or concavity. I would pick on concavity just because if f is concave down, that meant the second derivative would be less than 0. Well, if the second derivative is negative, then that's going to imply that my first derivative is decreasing. It is decreasing because the second derivative talks about the slopes of the first derivative. So let's go see, from 0 to 4 is my function decreasing. And so notice it is. We are looking for f prime. F prime is decreasing from 0 all the way down here to 4. So I know that one has to be correct. Didn't know that before I did this problem, but and I chose to do concavity again, not because, hey, I think that's the right answer, but I knew very quickly we could find where f prime is decreasing. So that tells me that the correct answer should be E.